Hey, AP Calculus, happy Friday. Today we're going to take a look at 4 new derivative rules in order for you to be ready for your quiz on Friday. They are e to the x, the natural log of x, and 2 familiar trig functions, sine of x and cosine of x. We're going to look at the 4 rules, why they are the way that they are, and then apply them to our product and quotient rules. Okay, let's go ahead and get started. So the derivatives of sine and cosine. I'm going to start with these because they're probably the most familiar to us. The derivative of sine of x is equal to cosine of x, and then the derivative of cosine of x is equal to negative sine of x. Please make sure you're aware of this, okay? And here's why. If we look at the blue graph in the first right here, that is the cosine of x. And if we look at the red graph, that's the sine of x. Look at where it's equal to 0 here, okay? For sine of x, it's equal to 0 at pi over 2. Look what's going on with the cosine, though. It crosses over from positive to negative, which means that this is going to start decreasing until we get to the next place where it kind of bottoms out and the derivative becomes 0. It goes from negative to positive, which means that it's going to be increasing after this point, and this repeats because our trig functions are always cyclical. So it'll keep increasing, decreasing, going from 0 to positive to negative over and over again. And if you look at the graphs of the cosine of x and negative sine of x, the same pattern exists, where when we top out right here at x equals 0, this is where the derivative crosses from positive to negative, implying that this is going to start decreasing until we get to the next 0 in our derivative, where it goes from negative to positive, which means that this is going to start increasing. And once again, that pattern repeats. If we look at the derivatives of e to the x and the natural log of x, these rules are pretty easy to remember, especially e to the x. The derivative of e to the x is equal to e to the x. And the derivative of natural log of x, as long as we're using the absolute value of x, is equal to 1 divided by x, or 1 over x. I want us to appreciate a little bit here the derivative of e to the x. This tells me that at any given value, if we take the derivative at a certain value here, the slope of the tangent line is equal to that value. So for instance, if we take the derivative where y is equal to 1 at e to the x, the slope of that tangent line is equal to 1. Likewise, if I do it at 2, the slope of that tangent line at y equals 2 is going to be 2. Same thing if I do it at 4, the slope of the tangent line is equal to 4, and so on and so forth. This has great application in higher order calculus classes such as Calculus 3, as well as differential equations. So if you're interested in taking higher level math at the college level, this will come back. Okay, and then if we look at the graph of the natural log of x as well as the graph of 1 over x, take a look at, once again, the graph of ln of x is the red one. Notice how the derivative is always negative here. And then if we go over to the other side of it, the derivative is positive and it's always increasing. Natural log is always increasing here. Okay, let's go ahead and apply some of the rules we know already. Let's take a look at the derivative of 3x times cosine of x. Once again, we want to apply the product rule here. So the derivative of 3 to the x over times cosine of x, we take the derivative of each one of these individually. So we say f of x is 3 times x, g of x is equal to cosine x. Find the derivatives. Derivative of 3x using our power rule is just 3. And the derivative of cosine of x, like we saw in the previous slide, is the negative sine of x here. And we just apply our product rule here. So 3x times negative sine x, I move that negative sign in front of 3, and then 3 times cosine of x is our next one. And the sum of those two products give us the derivative here. So I switched these around so that way the negative was the last term. You can leave it the way it is, negative 3x times sine of x plus 3 cosine of x. I just did it because it looks nicer with the minus sign between them instead of having a leading negative coefficient. But if you want to write it both ways, I'm perfectly okay with that. Looking at the next example, the derivative of negative 4x times sine of x. Once again, set it up the same way. We have two separate functions, so f of x equals negative 4x, and g of x equals sine of x. Take the derivatives using our power rule as well as our definition of the derivative of sine of x. We get negative 4 and then cosine of x, and then we do our kind of crisscross multiplication here. So negative 4x times cosine of x, and then negative 4 times sine of x. If you want to, you can leave it like this, or you can rewrite it where you're having subtraction between those instead of having adding and subtracting here. Okay. Looking at some examples with exponential functions and natural log. Let's use the product rule for 6x times natural log of the absolute value of x. Okay. So if we have f of x equals 6x and g of x is equal to natural log of x, we get derivative of 6x is 6, derivative of the natural log of x is 1 over x, and then we just apply our quotient rule here, or our product rule. So 6x times 1 over x, and then 6 times the natural log of x. When we do this, the nice thing happens. When we do 6x times 1 over x, the x's are going to cancel. We're left with a constant value of 6 plus 6 times the natural log of x. No simplification there. If you want to factor out the 6, you absolutely can. But of course, when we use the quotient rule, things get a little messy, as is expected here. So let's take a look here. So if I have e to the x divided by x squared minus 1, because e to the x increases rapidly, so if we wanted to reduce it, or it kind of slows down, we could do this. So if f of x is equal to e to the x and g of x is equal to x squared minus 1, we apply our quotient rule here to find the derivative. So derivative of e to the x is just e to the x, and the derivative of x squared minus 1 using our power rule is 2x. So what we're going to do is we're going to take the derivative of our first function of our numerator and multiply it by the original function, which I put over here on the right side, and then f of x times e to the x, or I'm sorry, f of x is equal to e to the x times the derivative of the second function, the denominator. And that's what I have right here. So when we do that, we get e to the x times 2x minus e to the x times x squared minus 1. And when we simplify this, and of course our denominator is x squared minus 1 squared, we can leave it like this unless you want to FOIL it, multiply it out. And what you get is 2x times e to the x minus e to the x times x squared plus another e to the x. That numerator is a big mess, but unfortunately we really can't simplify it unless you want to factor out an e to the x, and we're left with x squared minus 1 in the denominator. Okay. So your homework for today, to get you ready for the quiz coming up, is to do the quiz 3 review that I've posted for you, and then there's also a Delta Math practice. Okay, so it's not required for homework, but if you want to get some practice before you start the quiz review, it's out there. It's labeled quiz 3 review. Okay, hope you guys have a great day, and I will see you today for class. Have a good one.